Hey there, so there's a couple of ways that we can do this problem. The things we know are we have a point, and then from this line we can figure out the slope. Since ours is parallel, they'd have the same slope. So I think you're all good for the over 3 and up 5. So our slope would be 5/3 and containing the point 1, 2. So that's kind of what we can get from the graph. And then we have a couple of different ways. Sorry, that was loud. We have a couple of different ways that we can solve that. So the first one, I could use y equals mx plus b. And again, I know that m was 5/3. And I know that I don't know b, that's the problem. And when you draw this, it kind of comes out somewhere around here. And you can't really read off the graph what it is. Sometimes you look out, you draw the line, you can just read the intercept right from the graph. This isn't that time. But we do know that we are containing the point x is 1 and y is 2. So I have an x and a y, an m, and an m, which means I can now solve for b. So we'll have 2 on this side, m is 5/3, x is 1, plus b, and so 5/3 times 1 would just be 5/3. So I'll subtract the 5/3 over, so 2 minus 5/3 would equal b. And I want to get this in terms of thirds so that I can do my subtraction. So we'll just do a quick little 3/3 right here to get a common denominator. So that will give me 6/3 minus 5/3, which would be 1/3 equals b. So that would make my equation y equals 5/3 and then x plus 1/3. And you'd only have to type this half of it because the y equals would be in front of the answer box, it looks like. So that's one way to do that. And then the other one, oops, didn't mean to do that. Let's see. How do I get it to... There we go. The other way to do this would be to do point slope form. And so that formula is y minus y1 equals m x minus x1. And it's basically just the slope formula. You can see if I divided over those x's, I'd have essentially y2 minus y1 or x2 minus x1 for slope. It's just the slope formula, but kind of solved for the y's. So we'll do the same thing. And in this case, the x1 and the y1 are our point, and the x and the y are going to be the variables in the equation. So this would look like y minus y was 2 equals m, which was 5/3, and then x minus x was 1. And I'll go ahead and distribute that 5/3 through, and I get 5/3 x minus 5/3, and then we'll add 2 to both sides to get the y by itself. So I have y equals 5/3 x, and then it's minus 5/3 plus 2, which is the same thing as 2 minus 5/3, which we just figured out is 6/3 minus 5/3, and there's that exact same plus 1/3 that we got doing it the other way. So both methods get you to the same spot, just a couple of different roads to the same place. Hopefully that helped.